everyone, today's video is going to go over glycogen regulation. First things first, you need to know which enzymes are regulated in that glycogen breakdown and synthesis processes. Here I have a very simplified glycogen template, and we know that glycogen phosphorylase is the regulated enzyme of glycogen breakdown, and glycogen synthase is the regulated enzyme of glycogen synthesis. This means that these two enzymes are controlled by the body so that glycogen can either be made or broken when need be. Next, it's important to understand the relationship between the two enzymes. They have a reciprocal relationship. This means that one is on or in the R state and the other is off or in the T state, and vice versa. They are turned on and off by covalent modification. The definition of covalent modification is covalently attaching a modifying group to change an enzyme's activity. We typically see this with a phosphate, an alcohol, etc., but in this case, a phosphate controls if the enzyme is on or off. Here I have a table and a very simplified diagram of glycogen metabolism to visualize that regulation. When glycogen phosphorylase is phosphorylated, the enzyme is on, and therefore breaking down glycogen. A good way to remember this is GPP is equal to glycogen phosphorylase positive, meaning that the phosphate is there and the enzyme is on. If the phosphate is not there, glycogen phosphorylase doesn't have the positive, so it'll be off. Now, when looking at glycogen synthase, we know that through reciprocal regulation, if glycogen phosphorylase is on, then GS or glycogen synthase has to be off. So when glycogen synthase is phosphorylated, it will be off. If the phosphate is not there, glycogen synthase will be on, which is opposite of that of glycogen phosphorylase. Finally, let's connect how hormones control glycogen synthesis and breakdown in this table. For starters, we know that insulin is released when your body has high blood sugar. Because we want equal amounts of glucose in the blood and the cells, and because there's more glucose in the blood, we're going to want to push the glucose into the cells. Since more glucose is being pushed into the cells, we're going to want to make the glycogen because we need to store it. Therefore, glycogen synthase will need to be activated since we're synthesizing glycogen. And like we figured out in the last table, we know that glycogen synthase is active when it is dephosphorylated. Now let's look at glucagon. We know glucagon is released when our body has low blood sugar. And again, because we want equal amounts of glucose in the blood and the cells, we're going to push it into the blood. We're going to want to break glycogen or that storage of glucose so that we can put it into the blood. Therefore, glycogen phosphorylase is going to be activated because we're going through glycogen breakdown. And we know from the last table that glycogen phosphorylase is active when it is phosphorylated. Finally, let's take a look at epinephrine. Epinephrine is released in flight, fright, fight, and sex. And we're going to want that glucose in the blood so that it can travel to whichever muscles it needs to supply energy to. Therefore, we're going to need to break glycogen to get that glucose into the blood, and glycogen phosphorylase is also going to be on because we need to break down glycogen. And again, glycogen phosphorylase is on when it is phosphorylated. I hope this video helped, and thanks for watching.